Okay, we finally come to the last section in chapter 2, which is 2.8, which is linear inequalities. And remember at the beginning in chapter 1, I said that about 2% of what we do will be inequalities. These are that 2% and where they kind of fall into play. And it gives you a lot of different definitions with some A's and B's and C's and stuff like that. So I'm just going to keep it simple and just use entirely numbers. It's done the exact same way as how we saw, but the only thing we have to worry about is our greater than and our less than symbols. So if I have an equation, or actually it's an inequality because it doesn't have an equal sign, but if I have x plus 4 is less than 7. Now remember, we're always trying to find our answer to come down to a single number, but in this case, they're really not going to work that way. But anyway, if I look at this particular one, I solve it the same way I solve anything else, letters on one side, numbers on the other. So I'll subtract 4 from both sides. That allows that to disappear. So x is less than 3. And that means that when I graph this, we'll kind of go back to our number lines. Remember, everything on this side is negative. Everything on this side of the number line is positive. So I know that anything less than 3 will make this true. So if I use 0, 0 plus 4 is less than 7, so that makes it true. So anyway, this is telling me that anything less than 3. So I go over 1, 2, 3. And because this doesn't have a or equal sign to, then I make a open circle, and then I draw it at least past the 0, and I put the arrow. So that means that everything on this side of 3, which is all my negative numbers, and 2 and 1 and 0 and anything in between, will make this particular inequality true. Now, if I'm using this for an example, and I'm going to use the same one, but the only thing I'm going to make different this time is I'm going to make it equal or less than or equal to 7. Process is done the exact same way. Subtract 4 from both sides. That means that x is greater or is less than or equal to 3. So if I graph this one out, the only thing that's any different, because I have two different signs now, is this one is called a closed circle, and it's still graphed out the same way, but notice that this one is open and this one is closed, and that's the difference. If it's closed, it will have a line underneath of it, which means it's also equal to that number. If it's open, then that means it does not have one, and that means it includes every number except that to the left, or in case it's going to the right of that. Now, the only time it's any different than that is if your variable is negative. And what I mean by that is because if we graph this one out, I'm going to change it just slightly. So I'm going to say that negative x plus 4 is less than 7. So once again, I'm going to solve this just like I solve anything else. Subtract 4 from both sides. That allows that to disappear. So negative x is less than 7. I'll go ahead and draw my number line over here. So, because this is a negative variable, when we solve inequalities or equalities, and that's our equations, I have to use the opposites if it's a negative. So in other words, if this is a negative, I need to solve for x, not for negative x. And how I do that is I multiply it by negative 1. Whatever I do on one side of the equation, I do on the other. Anytime you multiply two negatives, you always get a positive, and that will give you a positive x. The only time that this is different than anything else is when anytime you multiply something by a negative, it causes this sign to reverse. So this becomes x is greater than, and then of course I'm going to just multiply these out. Well, I forgot to work that one out, but that's going to be with 3. So that's going to be a positive times a negative, which is going to be negative 3. So that means that everything that is true here is going to be an open circle. And because the arrow is pointing to the right, that always tells you which way this goes. So notice that these are all pointed to the left, so therefore my arrow is pointed to the left. On this one, I've changed it, I've reversed it because I multiplied it because it was a negative variable. That means everything going to the right, so it's going to look just like this. Just make sure you go by the 0 and graph it out. Now, it could be something that looks similar to this. So for an example, and then we're just going to check and see if it's true, is 0 and negative 0 is neither negative nor positive. So is 4 less than 7? Yes, that makes that true. So if I used a 5, is negative 5 plus 4, which is negative 1, is that less than 7? Sure it is, right? So if I go down to, let's say, negative 10, a negative and a negative is going to give me a positive, so 14 is not less than 7. So any big number out here in negatives would not make that true. So that's how you can kind of check these. But once again, I'm just going to draw out my number line, put my 0. So if I have negative 3x is equal to equal to, doing an equality, or doing an equation rather. But anyway, let's say that this one is pointed to the left, so this is less than 6. So once again, do the same process. I have to divide both of these by -3. Anytime I multiply by a negative or divide by a negative, I have to reverse the signs. So this is when it comes x is greater than, I have a positive and a negative, which is going to be a -2. And that's going to tell me that that's my inequality. So when I graph this out, I go to -2. It doesn't have a line under it, so it's a circle. Because I reversed the sign, it's pointed this way. So anything to the right of this makes this true. And the easiest way to check it is just by going to 0. So at some point, generally these will cross 0, but not always. But that's generally, if it does, that's always the easiest to look. Is 0 greater than -2? Yes, because 0 is greater than any negative number. So I know that this one, in fact, makes that true. So these ones are fairly simple. The only challenge to this, really, or not challenge rather, but the only 2 steps on this is it an open or a closed? Is it greater than or equal to? Right? Does it have a line underneath it or it doesn't? If it doesn't, then it's an open circle. If it does, then it's a closed circle. Then automatically at the very beginning, if this is a negative number, you should automatically reverse your signs before you do anything. So you know if it's pointed to the left and you start out with a negative, it's going to go to the right. And I always do that at the beginning. So for an example, if I have, and I think it's just easier to do it at the beginning than it is at the end. So if I have -2x is greater than 10, once again, I know my answer is not going to be pointed to the right. I'm going to go ahead and fill it in here. And I'm probably going to circle it just so I kind of can keep track of it. And I'm just going to work it up in case I come across it anyway. I know it's always going to be pointed that way instead. But anyway, I'm going to divide both of these by -2. That allows this to just become an x. Negative and a positive, right? If I only have one, it's an odd number, so I know my answer is going to be negative. 2 will go into 10 5 times. So if I was to graph this one out, I'm going to go to -5, 1, 2, 3, 4, 5. And I'm going to do an open circle. And because this one is pointed that way, then my answer would go this way, and it would be pointed that way. Once again, I'm going to check that. Is 0 less than 5? No, it's not. It's greater than 5, right? Because it's to the right of it. So I know that that makes this one, in fact, true. So this one's a fairly short section, and that kind of concludes chapter 2. There's one more section, which is chapter 2.9, which is compound inequalities. You may use that some in your biology class, but they'll go over that again. So we're going to skip that one so we can move on to chapter 3.